Hello students, welcome on my YouTube channel Aradhyan's Tutorial Hub. Students, in last videos we have learned about real numbers, that is rational and irrational numbers. So in this video you are going to watch about decimal expansion of real numbers. So watch this video carefully. Here there are two cases when we divide numerator by its denominator. First case is about terminating decimal expansion. In this case, the remainder becomes 0. Okay, and decimal expansion ends after a finite number of steps. For example, here 1 over 2. Here quotient is 0.5. So its decimal expansion ends after one digit. There is only one digit after decimal point. Okay, in second example, 7 over 8. When we divide 7 by 8, we will get quotient 0.875. Here after 3 steps, the division ends up and we get remainder as 0. Okay students, so this case was about terminating decimal expansion. Okay, now second case, non-terminating recurring. Recurring means repeating decimal expansion. The remainder never becomes 0. Here in this case, the remainder never becomes 0. Means when you divide numerator by its denominator, this process will continue infinitely. Okay, and we will never get remainder as 0. But we have a repeating block of digits in the quotient. The second point is that we will get repeating blocks of digits. Means certain type of digit will repeat again and again in quotient. For example, 10 over 3. When we divide 10 by 3, we will get 3.333 infinitely. So here repeating number is 3. It is repeating continuously. In second case, 1 over 7. In this example, 1 over 7, when we divide 1 by 7, we will get 0.142857 and again 142857. So here you can see this is the repeating block. It is repeating after a certain time, after a certain step. Okay. The usual way of showing repeating block is to place bar over it. To represent non-terminating recurring decimal expansion, we use bar over repeating blocks. For example, 10 over 3, we will get 3.333 and so on. So we will represent it by 3.3 bar. We will place bar over 3. The repeating digit is 3. So we will place a bar over it. Okay. In second example, 1 on 7, here repeating block is 142857. So we place a bar over this repeating block. Okay. So this is a method to represent NTR decimal expansion. NTR means non-terminating recurring. Okay students, expressing NTR decimal form in the fraction form means non-terminating recurring decimal forms in fraction form. How can we express NTR decimal forms in the fraction forms? So watch this carefully. Here we have an example in question form. Show that 0.333 that is infinitely. Okay, so we can represent it simply 0.3 bar. Show that 0.3 bar can be expressed in the form of P over Q, where P and Q are integers and Q is not equal to 0. So in this question we are going to represent a NTR decimal form into fraction form P upon Q. So watch the solution carefully. First of all, we will assume this entire decimal form equal to x. So let x is equal to 0.333 and so on. Okay. Here repeating digit is 3, only 1. There is repeating number is only 1. So we will multiply it by 10. We will multiply this equation. Both the side will be multiplied by 10. Okay. So we will get 10x equal to, when we multiply this number by 10, we will get 3.333 and so on. Okay. Now in the next step, 3.333 and so on. This value is, this value is equal to x. So we will extract this part in the form of addition. Okay, we will represent this number 3 plus point, that is 0.333. When we represent this number in two parts, that is 3 plus 0.333, we can easily represent this number by, replace this number by x. We can easily replace this by x. Okay, next step, 10x is equal to 3 plus this value is replaced by x, because we have assumed x is equal to 0.333 and so on. Now we have 10x is equal to 3 plus x. Now solve this equation, transposing this x to the left side, and 10x minus x equal to 3. Now the next step, 9x equal to 3, and the next step, x is equal to 3 over 9, and okay, 3 equal to x is equal to 3 over 9, and simplify this, x equal to 1 upon 3. So this is our answer. We can easily represent x, that is this entire form, into fraction form, that is 1 upon 3. This is our answer. Okay students, I hope you can easily understand this process. Now next question is, show that 1.2727, that is 1.27 bar. Here bar is over 27. Okay, so we have to represent this entire form into P over Q. Okay, so watch the solution carefully. Here let x is equal to 1.2727 and so. Here repeating digits are 2, so we have to multiply this equation by 100. Okay, when we multiply by 100, we will get 100x equal to 127.2727. Okay, here we have to break this number in two parts, and the second part must be 1.2727. So we can easily replace this number by x. So we can split this number in 126 plus 1.2727. What's the next step? Okay, we can split this number into 126 plus 1.2727. So in the next step, we will replace this by x. Okay, like this. Now you can easily solve this equation. 100x minus x and equal to 126, and that is 99x upon 99x equal to 126, and the next step, x equal to 126 upon 99, and simplify this, you will get x equal to 14 upon 11. So this is our answer. Okay students, question 3, show that 0.2353535, that is 0.2 bar over 35 can be expressed in the form of P over Q, where P and Q are integers and Q is not equal to 0. Solution will be like this. Let x equal to 0.2353535. Here bar is over 2 digits. So we have to multiply it by 100. Since 2 digits are repeating, so we multiply equation by 100. And we will get 100x equal to 23.5353535 and so on. Similarly, like the last previous question, we have to split this number in such a way that we get the second part equal to this x. Okay, so we can represent it 100x equal to 23.3. Okay, plus 0.2353535. Here this part is equal to x. So you need a practice to break the number in such a way that the second part will be equal to x. Okay, the next time we will replace it by x and solve the equation like previous, and we will get x equal to 23.3 upon 99. Now remove this decimal point and place here 0. 233 over 990. This is our final answer. Okay, students. Now finding irrational number between two rational numbers. Friends, in last video you have learned about irrational numbers definition. Now this is the second definition of irrational numbers. We can define a number whose decimal expansion is non-terminating and non-recurring is called irrational. Non-terminating, non-recurring, this number is called irrational. So here there is a question, find an irrational number between 1 upon 7 and 2 upon 7. So solution will be like this. First get 1 over 7 equal to. So here we have changed 1 over 7, this fraction form, into decimal expansion form. And we will get 0.142857, and here there is a bar over this block. Okay, so this is a repeating block. Similarly, we can get 2 over 7 equal to. Here we can multiply this repeating block by 2 to get 2 over 7, and we will get 0.285714 and bar over this block. This is a repeating block when we divide 2 over 7. So we changed 1 over 7 and 2 over 7 into decimal expansion, and we have to find irrational number between 1 over 7 and 2 over 7. So just write any number in the form of irrational between these two decimal expansion. So we can write as irrational number between these two numbers like 0.150150150015 4 times 0. So here you can see 15 is common, but we increase 0 1 by 1. Here there is 1 0, here there is 2 0, 3 zeros and 4 zeros and so on. So there is no repeating block. Okay, there is no repeating block, or we can say there is not recurring digits, and it is also a non-terminating. Here 3 dots are representing, this is non-terminating, it goes to infinite. Okay, so and you can see here there are two numbers 142857 and here is 285714. So this number is between the both numbers. You can write another number like this 0.250 2500 25000 25 4 times 0 and so on. You can write another number you can write so many numbers like this: 0.160, 1600, 16000, and so on. Okay, so this is really very easy to write any irrational number between two given irrational numbers. Okay, students, I hope you have learned whatever I taught in this video. If you really like this method of learning, please like the video, and if you not subscribed this channel yet, so please subscribe so you can get more videos like this, and share your friends also so that they can also get these videos. Meet again in next video. Till then, keep watching Aradhyan's Tutorial Hub.